Good morning, lovely 13s. Right, buddies, here we go, our second lesson, my lovelies, on projectile motion. So, last lesson, here's what you learned again. You learned that when things are projected, which just means that they're launched into the air and they're only being affected by the force of gravity, that's what a projectile is. We learned that what you saw was the horizontal velocity of the thing that's projected stays the same, stays constant throughout the entire projection, whereas it's the vertical part that changes. So you could be accelerating upward like this skier is, like he's accelerating up, then he stops at his vertical height there, then he accelerates down, down. But meanwhile, horizontally throughout his entire journey, he's going the same speed horizontally, because the only thing that will impact upon him is like wind resistance, which is going to be negligible in the amount of distance that he ends up going. Like, he's not doing a big long distance ski jump, he's just doing a little one, like a trick jump, so he's not really, he's going at constant speed horizontally. Cool! So here's what we're going to do today. Objects projected at any angle. Last time we only talked about horizontally, so that was where somebody would just run and fall off the edge of a cliff, but more often than not, you'd actually project something. So if you were to like kick a football, you'd kick it up and you would kick it along. Same as like if you were golfing, if you hit a golf ball, you'd be hitting it upward and like horizontally as well. And same with most things. If you were to jump off a cliff into the water, you would leap before you ran off the edge, because it'd be bizarre to just run off the edge. So yeah, this is more real lifey, this one. And so, yeah, I'm going to really date when you can probably guess the year I made the slides in, because it's a question about Angry Birds, you lucky ducks, which I still maintain is a good game, even though it probably came out like more than 10 years ago. It's still good. And let's do it. Okay, here we go. An Angry Bird is loaded into a slingshot and is fired at 25 meters per second at an angle of 30 degrees to the horizontal. What is the bird's maximum height? Okay, I'm going to scroll out one to give myself a bit of space to write, and here we go. So, in the margins, here we go, my folks. Okay, what is the bird's maximum height? Well, here's what you're going to do, my folks. To start with, it's not as straightforward as last time. The bird doesn't just have a horizontal speed or just a vertical speed, it's actually got an angular speed because it's going up at 30 degrees. It's got an angle of projection. So this is, and this is going to make the question way harder. But I promise it really, really isn't. Okay, ready? It's only one more step. Okay, here's what I would suggest. First step is just label what the bird is doing. Okay, it's going off at 30 meters per second. Yeah? All you have to do is split it into horizontal and vertical. Bish, bash, bosh. We have here, it's an initial speed, so I'm going to call it UH, and UV. The initial speed horizontally, the initial speed vertically. That's 30 degrees in there, that's a given, and there you go, not playing games. Okay, the bird's path is going to look something like this. It's going to start off with that initial velocity that we're on about at 30 meters per second. Oh, drat, no, it's not 30, it's 25. Oops, 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 oops. Oh, the first 30 seconds I made a mistake. 25 meters per second, and this is 25 meters per second. And the bird's path is going to be something like this. It's going to be a parabolic arc, which ends up with the bird back on the floor again there. Cool beans? Okay, we're after the bird's maximum height, which is there. So what is it that we're after? Are we considering vertical or are we considering horizontal if we're after maximum height? Yeah, well that's it. We're considering horizontal. So what do you write? Well, my buddies, here's what you write. We're going to just do, well, we're going to consider vertical. So vert! And which way do you want to be positive? Yeah, sure, how about up? Because the bird is going up. Cool? Now suvat. S-U-V-A-T. Suvat. Okay, now we just have to determine what we know and what we don't know. Do we know S, which is going to be the maximum height? Well, no, that's actually what we're after, right? U, do we know U? Yeah, we do actually. Is it 25? Nope. It's 25 sine 30. Okay, it's 25 sine 30 because the U is actually going to be UV, and that's the entire new thing to it. So 25 sine 30, 30 it should say, oops, 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 is just, oh, it's just, oh, half, okay, that's okay, 12.5. So its initial speed is 12.5 meters per second upward. Cool beans? Cool. Its final speed. How fast is the bird going to be going vertically at the moment that it reaches its maximum height? Now, I'll give you a hint. We do know. What do you think it is? Well, if you said 0, you're absolutely right. And here's why. Because the bird gets shot up, and it goes up, 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 then stop, then down, 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 down. Which means that the moment that it switches between going up and going down, its speed must have been 0. That's why it's 0. Now, I set up was positive, so A is minus 9.8 meters per second squared. And we don't have time either. And we don't care about time either. So we just want S, and we need the one that doesn't have time in it. So which one's that? That's right, my buddies. It's V squared equals U squared plus 2AS. So let's do it. 0 squared equals 12.5 squared plus 2, negative 9.8 S. And now skipping right to the final answer, S equals, and let's do it. It's going to be 12.5 squared divided by open bracket 2 times 9.8. I think that's it, isn't it? Yeah. Okay. So I got the distance that he goes up as 7.97 meters. 97 meters as the maximum height. So the only difference in this question to what you did last time is this initial speed was a little different. Cool beans. Rightio then. B. For B, the question is, how long does he stay in the air for? Well, there's two ways of doing it really, my buddies. There is a way that I think is easier at this moment. Since part A was what is the maximum height, if you can figure out how long it took to get to the maximum height, it's just going to be double that. So if we get t in this equation here, which is the easiest way, we can just times it by 2 because these are quadratic, so they're symmetric. Which means you can just double. If you get the maximum height, you can double. So that would be brilliant. We can do that for sure. Or, if you didn't have to do part A, the total displacement, I'm going to do it the hard way. So I'm not going to do it the easy way. You should do it the easy way. I'm going to do it the hard way. Okay, you ready? Hard way. Because I think this will be an important skill later. Now, if you could do the hard way, I'm not going to consider getting the time to the maximum height and doubling it, which is the easy way, which is probably how you should do it. What I will consider instead is, oops, I thought that was supposed to be green. We'll go here, it's going to be our start point, and here's going to be our end point. So I'm going to do suvat with reference to this, okay? Well, let's do it. Suvat. So I'm considering start to end rather than considering the midpoint. My way is worse and harder. You should do it your way. But sometimes my way is necessary. That's what I'm showing you. Okay, so here we go. Displacement, my buddies, vertically. Well, actually, in my way, it's 0 meters. Because it starts on the floor and it ends on the floor. It doesn't matter that it traversed a horizontal distance. All that matters is that it started on the floor and ended on the floor vertically. Cool, cool, cool. U, the initial speed. Well, we're still dealing with vertical, so it's still going to be 12.5. Okay, V, the final speed. It's actually minus 12.5, but I'm going to pretend that you don't know that yet because of the, it's symmetric, so it would have to be. If it went 12.5 up, it's going to have to be 12.5 down if there's no wind resistance in this question, which we're presuming that there isn't. I'm going to leave a question mark though for now. A is going to be minus 9.8 meters per second squared because I have up as positive, which I haven't written yet. Up as positive. And time is actually what we are after, which means we need the one that doesn't have v in it, which is s equals ut plus 1/2 at squared. Cool beans? S is 0, so 0 equals 12.5 t plus 1/2 minus 9.8 t squared, which means we're going to get 0 equals 12.5 t minus 4.9 t squared. And oh no! We've got a quadratic, buddies! What do we have to do to sort out our quadratic? That's it, you've got to factorize, but fortunately there's no constant term in this one, which makes it nice and easy. I'm just going to pull a t. T bracket 12.5 minus 4.9t, which means our two answers are t equals 0, which does make sense. When is the displacement 0? Well, before it's launched in the air it's 0, And also this one, so if it were equal to 0, I'd end up with 4.9t equals 12.5, which means that t is equal to 12.5 divided by 4.9, 2.55 seconds. Cool. And there you have it. So how long is it in the air for? Well, 2.55 seconds. Cool, cool, cool. And finally, how far from the slingshot does the bird land for part C? So how far from the slingshot does the bird land? In this case, my buddies, we're not dealing with vertical, but horizontal, if we're trying to figure out how far it lands. So here's what we're going to consider. Hor! Pick a direction to be positive. Right, because it's moving right. And it's just sut, because there's no acceleration. It's not too bad, it's sut. Now with sut then, do we know s, the displacement? No, it's what we're after. Do we know u, the initial speed? Well, yeah, it's from the triangle again. It's going to be 25 cos 30 this time, which is going to be horrible, I think. 25 cos 30. Yeah, it's horrible. 21.7. 21.7 meters per second. And time, well, 2.55 seconds. Cool. And once you got that, it's not too bad at all. S equals UT. S equals 21.7, 2.55. So S equals times 2.55 equals 55.2. 55.2 meters. So horizontally along the ground, the bird goes 55.2 meters. Vertically, its displacement though is 0 because it ends up on the floor. And the final one, what is the velocity of the bird, including directions 2 seconds into its flight? You can tell I'm being a bit lazy. Without wanting to make your video super long, I think you can do this one on your own. Here's what you need to do. Oh, should I just not be lazy? Should I just not be lazy? No, I'm going to be lazy. I'm going to make you do this one. Okay, you should pause the video and try. You should pause the video and try this. Here's what you need to do, my buddies. Get how fast you're going vertically to start with. So suvat, and in your suvat, you're going to have this. 2 seconds in, well, S we don't know, because we don't know how far up or down it is in 2 seconds in. U is still going to be 12.5, because it is the vertical speed, meters per second. V we don't know, that's actually what we were after. A we know is minus 9.8 meters per second squared, and we know that this is 2 seconds. So you can get V off of that. Horizontally is easy though. Horizontally, you already know that V is just going to equal 21.7. Yeah, meters per second, because it stays constant. So if this is 21.7, then this is 21.7. Cool beans? I've already done it now, so I may as well finish it. Oh, I said I wasn't going to do it. No, I am going to. I feel compelled to finish it now that we've started it. Okay, so what you got to do is get V off the vertical to start with. No, you pause. You do it. Go. You pause. Okay, and you're back. So let's check it out. Start with the vertical. Well, the vertical bit, I've made it sloppy now. I should have planned to do this question. We need the one that hasn't got S in, which is going to be, which one is the one without S in? Which one is the one without S in? V equals U plus AT? Yeah, that's the one. V equals U plus AT. We're after V, so V equals 12.5 plus minus 9.8, and T was 2. So the vertical speed is 12.5, take away 9.8 times 2, so we have negative 7.1. Negative 7.1 meters per second, which is fine. We said that up was positive, or we've implied that up is positive, which just means it's 7.1 meters per second downward, which actually makes sense. It's on the downward trend here, because you remember a minute ago we determined, or we didn't determine anything, like, because I skipped that part of the question. Yeah, which just means it's on the downward part. It's somewhere over here, okay? 2 seconds is somewhere over there, okay? Well, if the whole thing takes 2.55, then 2 seconds is way past the halfway point. Cool. Horizontally, though, so there's your velocity vertically. Your velocity horizontally, though, is just the same, 21.7 meters per second to the right. Which means, buddies, you're just going to combine them now as vectors. So let's do it. So let's do horizontal first. 21.7 followed by vertical. of 7.1. So our resultant one is there, our total V is there, and that's it, that's theta there. And let's do it. So to get V, it's just going to be Pythagoras' theorem. V equals the square root of 21.7 squared plus 7.1 squared. And let's do it. Square root of 21.7 squared, take away, no, plus 7.1 squared equals 22.8. So V equals 22.8. To get theta, tan of theta is 7.1 over 21.7, which means theta equals shift tan of 7.1 divided by 21.7 equals 18.1. 18.1 degrees. So final answer for part D is this. For part D, the velocity is equal to 22.8 meters per second in a direction of 18.1 degrees below horizontal. Cool? So we got it, my buddies. Hooray! I thought I was going to skip it, but we did it anyway. But I hope you got it too. Okay, one more one. It's just a bit of a trick question, this one, but it's still not too bad though. So here we go. A second angry bird is launched from the slingshot and lands perfectly on his target, important point, also at ground level. The bird reaches its maximum height 2 seconds after the projection and is traveling 7 meters per second at that instant. What is the initial velocity of the bird and the angle of projection? Okay, this question's a little bit harder, but I reckon you can do it. If you lay it out just like this one, you're going to end up with a muddle. But you know what? Try it anyway. See if you can do it. I think you should push pause and try it without me. But I know this is a rather large extension, so if you're stuck, that's okay. I'm going to tell you how to do it in a sec. But yeah, for your own good, have a little go. You ready? 3, 2, 1, pause. Okay, and you're back. So let's see. Here's what I'm going to say. It wants the initial angle. It wants the initial velocity of the bird and the angle of projection. So yeah, let's do some completely different colors here. Let's go with red. Oops, that's green. Let's go with red, and let's go with purple as well. Okay, so it's after this then, buddies, for part 2. We want the initial angle of projection. Well, draw a little picture to help, okay? That's going to be it there. That's the initial, that's the initial velocity. And it's got two components. It's got UH, and it's got UV. And it's got an angle as well. That's the angle of projection. That's your theta there. And all we got to do, buddies, is we got to figure out those velocities and the angle of projections. We're after U and theta. Now, to start with, my buddies, I think you also need a picture here because it's a bit nasty, this question. So the bird goes off and it shoots up to a maximum height. Then it comes down and it smacks its target down there, okay? Now, the only information it's given is that it reaches its maximum height 2 seconds in, so it takes it 2 seconds to get to there. And at that time, it's going 7 meters per second. Now, the really important thing to remember is this is a horizontal, so this speed is completely horizontal because if it's at the maximum height of the projection, that means, buddies, that it hasn't got any vertical speed. It's finished going up, but it's not yet started coming down if it's at its maximum height. So vertically, this way to this way, is actually nothing. So the 7 meters per second is all we've got. It's actually a result though, because look, that means, buddies, that the horizontal initial speed is also 7 meters per second, because that wouldn't change. So in order to get in order to get U, we just need to know UV, which means it's suvat time. So let's do it, suvat, and let's go vert. Pick a direction to be positive, how about up, and then suvat, suvat. Okay, first things first, do we know how tall it is off the ground? We know S, the maximum height. Oh, and I'm choosing the maximum height as well, just because it's the only kind of landmark that I have in this question. So the 7 meters per second and the 2 are only from the maximum height. That's why I have to pick it. So S, do we know what S is? The maximum height? Well, no, actually. Do we know what U is? No, either. But we do want U. That's actually what we're after. V. Do we know what the final speed vertically is? Well, yeah, it's actually 0, because we are at the point of the maximum height. Do we know the acceleration? Yep, minus 9.8 as I have up as positive. And do we know time? Yeah, it says it takes 2 seconds to get there. Sweet. So we need the one without s, which is v equals u plus at. Cool? So let's get it. We know that 0 equals u plus minus 9.8 times 2, which means that u is equal to, so mark for your inline substitution. Now just one mark for the final answer. I think it's 19.6, so I'm going to check. 19.6, yaha. So u equals 19.6 meters per second. Cool beans? Right. So there you go. 19.6 meters per second. So absolutely crushing it. We're flying. This 7 was this 7. This v, this initial v, the initial u I should even say, is this one. So what are we going to do? Well, we're ready to go for it then. We can answer the question now. So to answer part A, what's the initial velocity? Well, let's get it. U then is just going to be the square root of 19.6 squared plus 7 squared. So u, the initial velocity, is going to be 19.6 squared plus 7 squared. 20.8 meters per second. Get the angle as well. Tan theta, just because I don't want to, in case I got it wrong, in case I got this wrong, tan is the safest bet. Tan theta is 19.6 over 7, which means theta is equal to shift tan 19.6 over 7 is going to be 70.3 degrees. So for our final answer, what's the initial velocity and the angle of projection? The initial velocity u is 20.8 meters per second with an angle of projection of 70.3 degrees, and this time above horizontal. Always giving them to horizontal because that's how people's brains work. There are occasions where you give it as vertical, but people are more often than not confused by vertical directions. So if you do horizontal, people are like, oh yeah, it's tipping up or tipping down. So horizontal is always the way to go, never vertical. Cool. And for part B, how far away is the bird's target? Okay, I'm definitely scheming this one because I don't want this video to take ages. So for part B, how far away is the bird's target? Right then, my buddies. Well, it was at its maximum height in 2 seconds, okay? Yeah, that took 2 seconds to get to the maximum height, yeah? Right, how long is it going to take to hit the floor? Yeah, 2 more seconds. That's abusing the fact that this thing is completely symmetric, okay? All of them are. If there's no wind resistance, they are symmetric, okay? They're quadratic, these formulas. Like if you think of S equals ut plus 1/2 at squared, that is a quadratic formula. And so these are, yeah, they're quadratic, so they have symmetry. So there you go, how exciting. So let's do it. So for part B, how far away is the bird's target? It's horizontal, so consider horizontal. Hor, pick a direction to be positive. Right. Suvat or Sut? Well, Sut, because there's no acceleration horizontally. And here we go. So S, do we know that? Nope, it's what we want. U, the speed horizontally, do we know that? Yeah, 7 meters per second. So you got to keep being careful because there's lots of speeds given. But yeah, it's the 7 because we're after horizontal. And time, well, 4 seconds. Cool? S equals ut. S equals 7 times 4. S is 28. Like a boss. And so that's it, my buddies. I would actually say that that's an example of a hard one. So if you've got your head around this, you pretty much will largely have your head around all of them. I might give you a practice lesson on this because you can also chuck vectors in, but vectors won't make it harder. Vectors is actually doing half of the work for you, even though they're awkward. So yeah, really good work. I hope you're okay on it. Here's what I'd like you to do for the rest of this lesson. Have a little go at those. It's page 117, question 1 to 16. Do a mix. I think it's way too many questions, so do a proper mix. And I think next lesson I'll have a really good look at what the next topic is, and potentially we could have a lesson of practice, or if it's just a small more topic. I think it's the equation of trajectory next. And that's kind of a small wee topic, so I might just bust onto that one, but if not, practice is coming anyway, my buddies. But do what you can today, get as many of those done, upload them onto Google Classroom for me, and that's it from me. So see you next time. Bye, buddies!